All right. Now, the last property of light. The last property of light that we need to know about right now. We're not done for the day after this. We still got more stuff to talk about. But the last property of light... Oh, and of course it would freeze again. There we go. The last property of light is... Put it over here. Energy. Because a very important thing about light, and actually all waves, is that what they carry is energy. No matter what's actually waving, it always carries energy, okay? But not every beam of light carries the same amount of energy, okay? Not every beam of light carries the same amount of energy. So, how do we know how much energy a beam of light is carrying? We use one final small equation. Check this out. E equals HF. Okay. So, of these letters here, E equals HF, you could probably figure out what E is, right? E is energy. So this is an equation that tells you how much energy a beam of light has. If you look over here, F is frequency, so the only new thing is this H. And that H stands for Planck's constant. Planck's constant. I'll write that down. Planck's constant. Which is named after another scientist who studies light. But check this out. Here we go. Planck's constant here. It's a constant. It's just a number. It might as well just be the number 2 standing right there, okay? Don't worry about exactly what number it is. It's just a number, and it can't change. So, therefore, according to this equation, what's the only property that the energy of a beam of light relates to? What is the only property that determines what the energy of a beam of light is going to be, according to this equation? Remember, this is not a property, it's just a number, okay? So what's the only other thing in this equation? Energy just depends on frequency, okay? It just depends on the frequency, all right? So, let's put that together. In this equation, here we go. Give me something here. Give me something here. In this equation, if the frequency goes up, if we made the frequency a bigger number, what would that do to the energy? Okay, if the frequency is bigger, and remember, this is just a number right here, so that never changes. So if we make the frequency bigger, what would happen to the energy? Would it go up or down? It would get bigger, okay? It would get bigger. So all this tells us is that the energy of a beam of light is determined by the frequency, and the higher the frequency, the higher the energy. So let's go back to these beams of light right here, A, B, and C. Sorry, they're in a weird order. Which one of these would have the highest energy? A, B, or C? Which one would have the highest energy? C. C. That is correct. C would be the highest energy. That is correct. Because we said C has the highest frequency, that means it has the highest energy also. And A would be the least. That's correct. That's correct. A would be the least. Because A has the lowest frequency, so the lowest energy. So, let's put it all together. I put this all together into something that I call the 3 L's, okay? And I'll write this down because this is super important. The 3 L's. And by the 3 L's, I mean 3 things that start with the letter L, okay? This right here is super important, okay? Let's check this out. All right. 1, 2, 3. Longer wavelengths oops. Sorry about that. Longer wavelengths mean lower frequencies. Okay. And let's see if we can figure out what the last one is, okay? This right here is going to get you a lot of test questions right, okay? At least a few, all right? Longer wavelengths mean lower frequencies. Can you figure out what the third one's going to be? Longer wavelengths mean lower frequencies. And lower energies. Lower or less. Lower or less would work here, okay? So longer wavelengths mean lower frequencies and lower energies. So if you've got 2 beams of light, you only need to know one of these things to know the other 2, right? So if you had 2 beams of light and you know that one of them has a lower energy than the other one, then that means it also has a lower frequency and a longer wavelength. Or if you just know about the wavelengths, if you know one of them has a longer wavelength than the other, you know it also has to have a lower frequency and a lower energy. So in other words, the 3 L's always go together. The longer one is always lower and lower. Okay? All right. Now let's use this.